Screen is visible?
Yes, sir.
Yes, sir.
Okay. So the previous class we have already discussed about the types of digital voltmeters, multimeters, or Q meters. We have already discussed. The next topic we'll go for that is called electronic counter. Today we are going to discuss about electronic counter like a energy and energy meter, electronic energy meter, and LED, LCD. So I think LED, LCD already you have studied. 22, 8 minutes, 27. Still some people are joining. Okay. So then also what I will do, I will explain just brief about that one to remind you people about the LED, LCD and the digital and electronic counter and all the things here. See this counter. अच्छा okay, light गया था, light आ गई. Just I will put for the charging also. So the electronic counter is nothing but it is going to count. The name itself, it is there. What is that one? It is count here. The number of pulses it is going to count. For that reason, different modes are there, which is operating in the frequency mode. It may be operating for the totalizing mode. Totalizing means it is just total number of pulses it is going to totalize that. And frequency mode, it is going to, whenever the input we are going to give in the form of frequency. The frequency we are going to measure in the period of time, in the form of time period. The ratio of two frequencies we can measure. Total time interval of us complete that waveforms we can consider particular time, and we are going to, we can average that value. Like that, different modes of operations are there for this electronic counter here now. Okay, so one by one we are going to discuss in this class here. So electronic counter is nothing but decade counter, we are going to call that one. It is going to count the pulses here now. Number of pulses, how many times it is pulse is given to that one here now. So this is also called as decade counter. It can be easily incorporated in a commercial test instrument called electronic counter. The decade counter itself we are going to call as electronic counter in the commercial test of the instruments where we are in the industries, manufacturing companies and all the things. We are going to use this one. This instrument we are going to use. This counter itself, it behaves like a totalizer here now. It by itself, it behaves like a totalizer by totaling the pulses applied to it during the time t period or time interval that a gate pulse is present. The gate pulse is present. How much for particular, for 1 minute, for 1 second, how many pulses are given it is going to count the total number and it is going to display that one. That is, by itself, it is behave like a totalizer here now. The totalizer work is to count the total number of pulses. It is going to count that one here now. Typical modes of operation are, it may be as, it can use or it can operate as totalizing mode or totalizing purpose. We can number of pulses, it is going to totalize. In the frequency mode, we can operate in the period mode or in the ratio mode, time interval and averaging mode here now. This averaging means two values we have to take average of that one, that is averaging mode also we can use here now. One by one we'll discuss here now. So this is the totalizing mode. Here the input we have given here now. If the switch is closed, how many pulses it is going to get, that is it is going to decade counter, it is going to count and it will give the readout value. If overflow is there, this one it is going to indicate that the overflow indicator we are going to use over there here now. That is called overflow indicator we are going to call here. Overflow it is going to indicate here now. So it is going to count during the switch is closed. On that time, how much time pulses or input signals are given to this AND gate, it is going to count. That is called decade counter we are going to call here. See, in the whatever simple explanation is there, only for the input what it is going to do. That's it, enough here now. Still some people are joining, some people are leaving the meeting. I don't know. I'm not understanding what is happening here. So in the totalizing mode, the input pulses are counted by the decade counter here now. How many input signals or pulses we have given, it is going to count along with, as long as switch is closed here now. If the switch is closed, then it is going to count that one here. If the count pulse exceeds here now, if exceeds the capacity of this counter here now, exceeds the capacity of counter, the overflow indicator is activated and counter starts continue again here now. It is going to overflow, it is going to indicate that one, so it will stop and it will starts continue for the next cycle. It is going to consider here. See here, I think in your syntax you are going to switch on the motor. If when it will flow full, it is going to overflow, yes or no? Like that, the counter capacity is full, the input signals it is going to give that one. It should not understand that it is full or not. So for that reason, we are going to use the overflow indicator. We are going to use this overflow indicator. It is going to give a signal to this one. It is overflow or it is capacity is full. So on that situation, what will happen? It will stop and it will start for the next counter, that is called it continue again for the next second cycle, we can call that one here. So this is called totalizing. Only number of pulses it is going to count that one. That's it. The frequency mode what we are going to give for different frequency up to 1 kilo megahertz we have given here now. Plus 10 we can give, plus 10 we have used some variable switches for the frequency here now, and here the input signal is there. Here the input signal is there. Whatever the previously the gate we have used, instead of the supply voltage, we have used frequency here. We are giving the frequency here. Now it is going to count the pulses here now in the form of frequency. So that is called the frequency mode we are going to operate here. Now the input signal is given here. The frequency 1 megahertz is there, plus 10 that is added here. Now if it is connected to here, this switch is connected to here, that is 1 megahertz. Then 1 megahertz plus 10 here now, plus 10, plus 10, plus 10, plus 10, like that. The different variable frequency we have used here now. So for variable frequency, we can count the decade, we can count the number of pulses here. The operation is same like a totalizing here now. Same like a totalizing here also, it is going to count number of pulses only, it is going to count here now. So there is no overflow and all the things here now. That is directly it is going to whatever the values pulses are there, it is going to give here now. That is digital value, it is going to read out that value here. The gate pulse we have provided here, it is going to take the frequency here now and it is going to count that counted value, it is going to read out here now. So some formulas is also there. Can anyone tell me what you mean by frequency? Definition? Definitions. That one also you don't know. Number of cycles per second we are going to call. That is nothing but here we are going to consider that number of pulses divided by time we can consider for the frequency. Or for the considering the time period, it is F is inversely proportional to the time period. Yes or no? 1 by T. Time period. Is it correct?
Yes, sir.
Yes, sir.
So both all the formulas are useful here now for the frequency. If the time interval in which the pulses are being totalized is accurately controlled here now. During a time interval, whatever the pulses are given here now, those are totalized and accurately we have controlled by giving the gate signal pulses to the gate signal here now, and the counter operates in the frequency mode here now. So the accurate control of the time interval is achieved by applying a rectangular pulse of the known duration to the gate here now. And gate we are going to call here now. See here which pulse it is nothing but rectangular pulse only. Yes or no?
Yes, sir.
The rectangular pulse we are going to apply to get the accurate answers or accurate control here now. So we have applied the rectangular pulse to the AND gate here now. In the place of DC voltage source, that is for the DC voltage source they are telling here now. So a block diagram, same thing we have written here. Block diagram. See here. Here the totalizing formula we are going to consider here. In the totalizing mode, the input pulses are counted here now. How many input pulses are there? That is counted here now. That is pulse counted. That is called N here now. Number of pulses I am going to consider as N by the decade counter, as long as switch is closed here now. For the frequency switch is closed here now. If the count pulses exceeds the capacity of the decade counter, overflow indicator is there already. That is totalizing counter we are going to call here now. So according to that, F equal to pulses counted divided by the duration of the gate pulse. How much for duration we have closed the gate signal here? For 1 second, 2 seconds, we have closed the gate here. That is called frequency of the input signal we can identify in the frequency mode here. See here, number of pulses for particular time period, for 1 minute, for 2 seconds, 30 seconds. So 30 seconds, there is around 60 pulses are there. 60 divided by 30, how much? 2 hertz, you can call that one here. Like that, we are going to, it is going to give the display by totalizing that one here. The ratio mode, in the ratio mode, what we will do, if two frequencies are there, we are going to take for the ratio of one frequency to another frequency for the simplifying purpose here now. So the ratio mode of operation simplify displays the numerical value of the ratio of the frequencies of the two signals here. Now, if two signals are there, it is going to display the numerical value here now. So the low frequency signal is used in the place of clock to provide the gate pulse here now. Low frequency signal, instead of clock pulse, we are going to use the low frequency signal. So the number of cycles of the high frequency signal which are stored in the decade counter during the presence of externally generated gate pulses read directly as a ratio of the frequency here now. Number of whatever the frequency signal it is stored in the decade counter, that is we are going to count in the ratio mode as the average value of that one when we are going to call here. Stored decade counter during the presence of external generated pulse is read directly as a ratio of the frequency it is going to, we can read here now. So there is no diagram for this one actually. Next we will go for the period mode here. So the time period we are going to call here now. So here the frequency 1 megahertz, the pulses, rectangular pulses we have given here also. F by F, frequency by frequency, that is also rectangular we have given. Two inputs for the AND gate here now. And here the number of pulses it is going to count in the decade and it is going to read out here now. So in some applications, it is desirable to measure the period of the signal rather than its frequency. Instead of frequency, some applications they are going to measure the time period. Time period they are going to consider over there. So on that situation, the frequency and time period are inversely proportional. So we can you calculate the frequency or you can calculate the time period here now. So number of pulses per particular time period we are going to measure here now. Since the period is reciprocal of the frequency, we know that one by T, capital T. The frequency already we have. I don't know how many of you know this one. F equal to 1 by t. Correct hai na formula? That is reciprocal here. No. Frequency is reciprocal of the time period, that is called t here. No. It can easily measured by using the input signal as gating pulse here. No. The input you can give the gating pulse as a frequency and count the clock pulses per particular time period. We can calculate the time period also. In the period of time period also we are going to get here. No. So previously what we have done, for particular time how many pulses are generated, pulses counted we have considered. Now what we have to do to calculate the time period, it is reverse here. No, t will go here, f will come here, and number of pulses divided by what is the frequency of the clock, that is going to give the time period here. No, the frequency we are going to giving the input as a frequency only. No? So the frequency of the clock, what is the frequency of the clock is there, that one we have to divide here. No, so number of pulses counted divided by the frequency of the clock, it will give the time period here. No, that operation we are going to call as time period or period mode operation we are going to call here. That is time interval. For particular value we have to, what is the time interval to complete one cycle, we can call that. Like that condition here, see here, three inputs are there here. Here we are using one decade divider. Again the frequency here. No, start and stop signal we have used here. Start and stop signal we have used here. No, so if the start is nothing but the AND gate is, we have given the signal to the AND gate. Stop is nothing but we have stopped the AND gate signal here. No, again it is going to count and it is going to read out here. See here, the time interval mode of the operation measures the time elapsed between two events here. Now, what is the time wasted in between start and stop here? Now, that one we are going to measure here. Now. So the measurement can be done using the circuit as shown in the figure. That is, so the gate is controlled by two independent inputs. This gate is, AND gate is controlled by two independent inputs we have controlled here now. So those inputs are the start input, which enables the gate here now. Start means it is going to enable the AND gate here, and the stop input which disables the AND gate here now. It is going to remove that one here now. During the time interval between the start and stop, the class pulses are accumulated in the register over there. Accumulated means it is going to store in the value of the registers. During the start and stop, the values they are going to store in the register, thus providing an indication of the time interval between the start and stop of the event here. No, that whatever the in between start and stop operation is there, whatever the values it is going to store in the accumulator, that one the electronic counters find and it is going to give the display of that one here. That is the time interval we are going to call for the during the operation of start and stop here. No, so the electronic counters find many applications in the research and development laboratories, especially in the research labs, commercial companies. We are going to use this one. The standard laboratories we are going to use, on service branches and everyday operation of many electronic installation. Wherever the electronic installation is there, we are going to use the all the types of any one type of the counters we are going to use. These are used in the communication to measure the carrier frequency here. Now almost your whatever the telecommunications are there, mobile networks and all the things, they are going to operate in the form of frequency only. So on that places it is going to use in a digital system to measure the clock, frequency, time period, everything it is going to consider here. So these are the different modes of operations of what is that one, electronic counter we are, or decade counter here. Next we will go for the electronic energy meter, we are going to call that one. See here, this is the electronic energy meter. आज सबके घर में इलेक्ट्रॉनिक मीटर है, एनर्जी मीटर है क्या नहीं?
Yes, sir.
See, I'll give one example that one. I don't know how many of you have observed that one. If it is electronic, आपका एक यूनिट होने के बाद एक लाइट ब्लिंक हो जाता है, उधर लाइट ब्लिंक हो जाएगा, देखा है क्या?
Yes, sir.
So, but previously we were using that is conventional energy meter. उसके अंदर एक व्हील रहता था, वो व्हील एक बार रोटेशन होके आया ना 1 यूनिट कंसीडर करते थे. ऐसा है क्या किसी के घर में व्हील जैसा रोटेशन इनसाइड? So that is called conventional, the which one that operated based on the electromagnetic principle it has operated. उसको क्या किए बहुत सारे लोग ने वो मैग्नेट चिपका के उसको स्टॉप करवा दिए. So the energy meter which the bills were reduced over there. But here the electronic counter, electronic energy meter, what we are going to consider, they are not at all using any electromagnetic principle here. Now, what they are considering here now, they are going to measure the power for that is kilowatt hour. What is the unit of energy? Watt hour only, na?
Yes, sir.
Kilowatt hour. Kilowatt is nothing but what? Watt is nothing but power. Yes. Watt is nothing but power only, na?
Yes, sir.
Power, the what is the formula for the power? Product of voltage and current only.
Yes.
So what they are doing here now, the AC input we are giving here now. So the voltage it is going to process differently and current we are processing differently by using CTs here now. The current transformer we are going to use and shunt resistors we have used here now. So we have separately current processing unit and voltage processing unit and zero crossing detecting here now. If it is crossed zero, there is a then directly it is going to give the 8085 microprocessor chip it is going to give here. So this voltage processing is given to the analog to digital conversion and current processing is also given to the analog to digital processing here. What it will do, this analog signal is converted into digital and this chip 8051 microcontroller we have considered here now, electronic devices and circuits we have used here now, it is going to take the data, it will make the average of this voltage and current here now, it will give the product of voltage and current, that is nothing but watt it is going to give. So kilowatt hour per unit it is going to count that one and it is going to display here now. If 1 kilowatt per hour is nothing but one light, it is going to blink over there. 1 kilowatt hour is nothing but one light, that is called 1 unit here now. 1 hour के लिए आप 1000 watt use किए, that is called 1 unit. Like that it is going to use here now. What is the advantages? आप कोई देखे क्या? उसको इनपुट दिया तो ये ऑन होते, नहीं है तो नहीं है, बट इनपुट रिमूव करने के लिए परमिशन चाहिए. इफ मीटर ऐसे ही रन नहीं करने जैसा कुछ है क्या आइडियाज आपके पास? Previously is there, it was when the rotating wheel was there, it was there, but now the electronic is there, it is going to count in the pulses only here. One light it is going to blink as 1 unit here now. Like that it is going to operate here now. So if you physically the college started means I can show the energy meter also, it is there in our laboratory. We can open, we can give the supply and we can count the how much per one instead of hour I can give 1 minute time to complete one cycle. We can set that one. Based on that we can measure that one here now. That is practical is also there, but due to this online situation we have not conducted that one. So same explanation I have written here. The conventional mechanical energy meter is based on the phenomenon of magnetic induction over there. Magnetic induction based on the magnetic effect, the wheel is rotating. That one is it has a rotating aluminum wheel called as Ferrari wheel. We were calling that one. The wheel name is Ferrari wheel, and many toothed wheels based on the flow of current over there. Based on the flow of currents, it has tooth that one slots were there over there. So because of the error, wheel rotates, which makes the rotation of the wheels over there. The gearing system and like that we were using over there. So by connecting one is wheel is rotating, the other unit should have to turn upper side, lower side, the number it is going to display over there. So since many mechanical parts are involved in the mechanical defects, so breakdowns are common in that one. So the electronic energy meter is based on digital, what is that one? Digital micro technology we are going to use here now, DMT, digital micro technology, and uses no moving parts. In the energy meter अभी घर में use कर रहे हो, कुछ तो rotate हो रहा है क्या? There is no moving part at all, only the light is there. So that one, so that digital display is there, it is going to give the value over there. So the EEM, that is called electronic energy meter, is known as static energy meter here. Static nothing but if there is no moving parts, that is called static. Okay. So what it is done, In the electronic energy meter, the accurate functioning is controlled. We will get the accurate value of the reading, how much electricity we are going to use. Based on that, it is going to consider by especially designed the IC, that is called integrated chip, called that is application specified integrated circuit here. Application purpose specified for that application only, the ASIC has that chip is we have used, that is circuit, which is constructed only for the specific applications using embedded system technology here. Actually, you have, they have to keep embedded system and all the things for you people. It's not there for you. So that is just microcontroller. You consider that one. Based on that, it is going to give the signals here. In addition to the application specified integrated circuits, that is ASIC, analog circuits are there. Voltage transformers we have used, current transformers are also used to present in the electronic energy meter to sample current and sample voltage here. It is going to take the sample current and sample voltage here now. So the input data is compared with the programmed or referred value here. Input whatever the sample voltage and current it is going to collect here now, it is going to compare with the referred value or standard voltage and current here now. Finally, what will happen, the voltage rate will be given to the output. This output is then converted into digital data. The input is analog signal is given to the analog to digital converter, that is going to convert into digital. So that digital data we are going to consider by the analog to digital converters present in the ACIC circuit here now. So the digital data is then converted into as average value here. Whatever the voltage we have considered, that is average value we are going to get here now. So current and voltage here now. This value measuring unit of power here. The product of voltage and current only we are going to get the power value here now. So then the pulses are equal to the average kilowatt hour per unit here. 1 kilowatt or 1000 watt hour per we call as 1 unit here. Now per unit ke liye 1000 watt we have to use over there. So that is concept is very simple. When you will see the diagram, when you will see the product, then you will understand and you will get more idea about that one. Simply the diagram explain kiya to samajh mein nahi aate, but you can check your energy meter in your houses. But वो ऊपर का glass part है ना, वो open करने के लिए try मत करो. That was the live meter. You get the electrical shock. So it completes the electronic energy meter. So the last topic of the 5th unit is LED and LCD. Can anyone tell me the long form of LED and LCD? Any one of you?
Light
emitting diode.
light emitting diode.
LCD?
Light collecting diode.
Light collecting diode. Anyone? LCD long form? अभी तो कोई यूज नहीं कर रहे LCD, but पहले LCD था. Now all the things
Liquid
are
crystal display.
Which one?
Liquid crystal display.
Very good. The LCD is not a diode. Okay, it is a display. L is nothing but liquid we are going to use. C is nothing but crystal we are going to use. And D is nothing but we are going to use the glass material that is called display we are going to get here. So the light emitting diode that is called LED is there. So LED, what will happen? It is a one junction device, 2 layers are there. That is all of you have studied the diode that is called PN junction diodes. Yes or no? PN junction diodes are there. Whenever the breakdown will occur on that situation, what will happen? The current will start to flow from what is that one? Anode to cathode over there. 2 terminals are there. In that one, what will happen? This diode, whenever the conduction is there, on that condition, it is going to emit the light. The light will emit over there. For that reason, the diode name came as light emitting diode. It is going to emit the light, or light emissions will be there. So on that condition, the name came, that is called LED. So that is called light emitting display we are going to call here. So by using different material combinations, we can get the different colors also. In the function वगैरह आप देखा है शायद, different color का light ऑन हो जाते हैं अभी. पहले इतना बड़ा लैंप यूज करता था, अभी एक पट्टी आ रहा है चिपकाने जैसा. सिंपल, very simple is that here. So see here one layer is there, here another layer is there. The full form of LED is light emitting diode. The LED is a PN junction diode here. Now one is P and another one is N here. Now that is called diffuse P layer and N layer we have used here. Now P layers it has holes and N layers it has electrons are there here. Now so LED is a PN junction diode which emits the light when electric current flows through it in the forward direction. Forward direction is nothing but P को positive देना है, N को negative देना है. If it is positive to negative supply is given, then what will happen? It is going to emit, the current will flow, then it is going to emit the light over there. So that light we can give as a, can consider as a display here. So the LED is constructed by doping the P type and N type material here. Doping is nothing but we are going to add some materials inside that one here. We are doped P layer and doped N layer we are going to consider here now. When power is applied across the LED, the recombination of P type and N type material charges take place here. Here P type material and N type material, the charges will take place here now. So combination of P type and N type, whenever they are going to mingle or combine, recombination will be occurs over there. And that time it is going to produce some heat and light. It is going to produce some heat and light. That light we are going to utilize here. So the recombination of charges gives energy. It is going to give the energy in the form of heat and light. It is going to give here. That is we are utilizing here now. So LED is a semiconductor device or non-semiconductor device? Semiconductor or non-conductor? Non-semiconductor.
Semiconductor.
Semiconductor and conductor, what is the difference? Anyone can you tell? What is the difference between semiconductor and conductor? Anyone you can tell? Yes. Is there any difference? See, conductor means which allows the flow of electrons.
Semiconductor can work.
Take minute. Conductor is which is allows the electrons to flow into the circuit. Yes. But what do you mean by insulator? Insulator सुना है क्या?
Yes.
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 It will opposes the flow of electrons. So in between the insulator and conductor, it can sometime it is going to oppose, sometime it is going to allow. That is called semiconductor. It is not going to conduct fully. Semi, only some part. Example I will give here now. If it is forward biased, then only the electrons will flow from P type, P N type. If positive ko negative diye, negative ko positive diye, then what will happen? It is going to blocks the current here, no? Electrons it is going to blocks.
Yes, sir.
Or the reverse bias. That is called the semiconductor we are going to call. The semiconducting materials are there, different materials we are going to use. That is arsenide, galvanized, and some materials. Can you tell any names? Materials of semiconducting materials.
Silicon.
Silicon diodes we are going to SCR, that is called silicon. Next, germanium. So mainly we are going to use silicon and germanium only we are going to use. So to give the combinations, the semiconductor material used here now, galvanized arsenides we are going to use, which generates red, yellow lights here now. Combination of silicon with some material adding that one, we can get different colors we can get here now, that is green, red, amber color, yellow, we can generate here. So the several LEDs used for representing one segment and several points are represented by the single LED here now. One LED I have explained that one here. We can make that one 7 segment display, we can do that one LED. If 7 segment display here now, For one LED we are going to use here now 7 LEDs we are going to use for the display of this one here now. 1, 2, 3, 4, 5, 6, 7 here now. Yes, we can use for the 1 and 2. These two only it is going to operate here. This one and this 2. For the 2 this should not operate and this should not operate. Then it will become 2 here now. For the 3 it will operate, and it will operate. For the 4 1, this and this, like that here now. This is called 7 segment display here now. 7 segments we are going to use, 7 LEDs we are going to use. Each one we are going to do common cathode or common anode by circuits we can use here. All of you have studied, I think first year mein tha, maine padhaya, mere ko malum hai. Yes, so this is just semi means which act as conductor and insulator only. That one only we told you. So that is LED part you have considered here. Okay, so next LCD भी same रहते क्या? Positive P type layer, N type layer है क्या ऐसा? No, here what we will do, we are going to use liquid crystal. We are going to use here. This is the liquid crystal we are going to use, and whatever the in between this upper light yellow is visible, those are the glasses we are using here. No, in between this liquid crystal and glasses, whatever the white color is there, that is called transparent electrode we are going to use here. 2 electrodes we are using here now, and here mirror surface in the reflective type here. No, LED TV, LCD TV, मालूम है ना? Use किया ना LCD display. Previously it was there, but now everything is replacing. So what will happen? The LCD is used for the displaying the text, images, pictures, movies, and all the things we are going to use. So that is called dot matrix here. Now dot matrix we are going to use, that is called, that is segments here. So LCD has liquid crystal filament here. Now this is the liquid crystal we have used here now, which is filled between the transparent electrode here. Now, here one transparent electrode is there, here one transparent electrode is there. In between we have filled the liquid crystal we have filled here now. So the construction of, sorry, where it has, which filled between the transparent electrode. When the current passes through between the electrodes here, now the electrodes here is the, whenever you will give the supply, the current will start to passes through that one here. Now the filaments become the energized, emits the visible lights over there. They will get energized, and these filaments, what it is going to do, it is going to display or emits the visible light it is going to use. So by using a mirror here, now mirror surface we have used here now, so we can reflect that one into reverse order here now. Mirror, yeah, whatever it is going to display, the same thing, the display it is going to come on the TV over there. That is called liquid crystal display, that is called LCD display we are going to call that one here. So the construction of LCD or liquid crystal display is shown in the above figure here now. So the liquid crystal used in the display has the property of both solid and liquid here. See, this electrode is solid or liquid? Electrode is solid or liquid? I am asking to you people only. The glass is solid or liquid? Hello, is it audible? Hello, audible hai kya nahi?
Yes, sir.
So for that reason, the liquid crystal used in the display has the property of both solid and the liquid. It has both the properties are there. When the potential is not applied across the liquid, it becomes transparent, but after activation, the crystal scatter light in the direction and appears to be the bright here. Now, if any supply is not given, then it will act as a glass only. The whenever supply will give it here now, it is going to charge and emits the light here now, which is going to display over there here. So these are the some just the principle I am telling here now, and based on this principle you can differentiate the LCD and LED by comparing that one here. So here in deep they have written here now, definition of LED is nothing but it is a PN junction device here now, or diode, PN junction diode, which discharge visible lights. It is going to give the visible lights when an electrical charge passes through it. Electrical charge or current passes through it, it is going to give the light here. What is the LCD definition? It is also diode. LCD is also diode or not?
No.
sir.
No. Then the optical device we are going to use here now. That is called optical or crystal device here now for displaying the information in the form of text and images we are going to use here. This LED stands for light emitting diode. LCD stands for liquid crystal display here now. Backlight is there. There is no backlight is required for the LED, but for the mirror copy it is going to transparent. For that reason, cold cathode ray, that is fluorescent lamp, is provided backlight to provide the light visibility. So backlight is provided for the LCD. Resolution is very high for the LED, but for the LCD it is low here now. So power requirement for the LED is high because it should have to break the breakdown junction between PN junction. It should have to break. So the power required is more. Here for the LCD, power required is less. The display area is very small for the LED. So many LEDs we have to use for making the panels over there. But the LCD the display is very large. You can use here now. The cost of LED is very high, but cost of LCD is low. Comparing now, it is day by day competitors. The technology is increasing. Both are same only we are going to consider. So material used for the LEDs, gallium arsenide to get the phosphide, silicon, germanium. So for the different colors, we are going to use the combinations of that one, red, green, that amber, yellow colors. We are going to use that one here now. But the material used here now for the display, that is called liquid crystals and glass electrodes only we are going to use here. The switching time is very fast for the LED, and for the LED LCD, it is very low. It will take some time. So for that reason, the switching time is slow for the LCD. So DC direct current do not affect for the LED. It may be AC or DC. DC only we are going to use the converter. सब LED TV को अभी adapter आ रहा है मालूम है ना? Adapter रहते क्या नहीं?
Yes.
That is converted, is going to convert that one here now. So it will not affect, but for the LCD TV, it is going to reduce its lifespan. So much heat will be produced and its life will be reduced for the LCD here now. The constant ratio is low for the LED and high for the LCD. And mercury tube, we are not going to use any mercury tube for the LED, but for the LCD, once that's like slope, we have used mercury tube, we have used. I think old TV है तो थोड़ा open करके देखो आप लोग. Old TV में LCD display use करते, we can check that one, and you can check that one. Side में बैठा तो भी नहीं दिखते हो, straight बैठना चाहिए. Like that, liquid crystals over there are there on that one. So these are some comparison of LED and LCD we have compared here now. So it completes the 5th unit, and tomorrow we'll start the 6th unit of that one. Maybe in the afternoon. See, all of you have the MCQs. You can prepare for the chapter test. I don't know when I will conduct. Anytime I can conduct the chapter test on this 5th unit. See, hardly to finish the 6th unit, I required very less classes. So maybe due to this Sobus activity, we have some classes were cancelled. So we'll recover that one up to Wednesday. We will try to complete the syllabus, I think. This end, March 1st onwards, you have to join. I will put the link for the revision. Revision के लिए start करेंगे अभी. Section 1 is already over. For the section 2, we'll revision that one by combining that A and B division. So anything you want to ask? Yes.
No, sir.
I'm asking to you people only. आवाज आ रहा है क्या नहीं?
Yes, sir.
So 5th unit is over, and tomorrow we start the 6th unit. Saturday, Sunday, Monday we'll finish Saturday, Monday, and Tuesday. Maximum Tuesday or Wednesday will finish the syllabus. Okay, so be ready for that one. Still, so many people who have not submitted the lab work, and who has not submitted the test, unit test 1, unit test 2, unit test 3, 4 to complete it. It will affect for you people on the term work marks. Remember that one. And maintain the attendance also. I will call the roll numbers. I'll take the attendance just a minute. Roll number 1, just say yes.
Present, sir.
2, 3,
Present, sir.
4, absent. 5,
Present, sir.
6. Roll number
Yes, sir.
7, 8, 9. Roll number 9. Okay. 10 is not there. 11,
Yes, sir.
12, 13,
Present, sir.
14, 15, 15. देखो ऐसा रहते मीटिंग में तो है बट यस बोलने के लिए टाइम नहीं उनको. 16, who will not tell yes, I will put absent. Roll number 15 is absent only. 16, 17,
Present, sir.
18,
Yes, sir.
19, 20, 21, 22, 23, 24, 25,
Yes, sir. 23, sir. Yes. 24.
27,
Sir, 25 present.
27, 28, 29, 30, 31,
Yes, sir.
32, 33, 33, 34, 33 है क्या? नहीं है तो मैं कुछ नहीं बोल रहा हूँ. 34, 36,
Yes, sir.
37,
Yes, sir.
38,
Present, sir.
39, 40, 41,
Yes, sir.
2,
Yes, sir.
43, 44.
Present, sir.
Roll number
Hello,
4,
sir.
7, 8, 9, 10, 12, 14, 15, 16, 17, no, 17 present, 20, 24, 25, 26, 27, 28, 29, 30, 32, 33, 34, 35, 36, 37, no, 36, 40, 43. These are the absent numbers.
36 present, sir. 16 present, sir.
क्यों बोल रहे हैं? पहले ही कहाँ गए थे? सो गए थे क्या?
Sir, 25.
36, sir. 16.
Together.
15.
Message करो बस.
16.
In the text box you type your roll numbers. Roll number 15. Okay, I will change. Roll number 15 is present. 16 is present. 33 is present. 25 is present. Okay. 24, 20. Okay, next.
36.
You told means I will not listen. You have to message. Chat box में लिखो. It will record that one. Okay. 36. So we'll stop here only. अच्छे से preparation करो थोड़ा. Wait, be ready for the test, chapter test 5 and chapter test 6 also. I don't know any time I can conduct chapter test 5 and 6. It will not take much time for the 6th unit. I already told. Once again, I am repeating you peoples. Be ready for the chapter test and for the completion of syllabus. After completing, immediately I will plan for that one. We have submitted the, what is that? Lab book. I will check that one, and maybe ISC 2 will come. ISC 2, 4, 5, 6. All 6 unit, 3 units are there. Unit 4 and 5 and 6. Okay. Be ready for that one. Prepare well. Okay, we'll stop here only, and tomorrow we'll start the 6th unit.